Hello everyone and welcome to iptutor.com. My name is Vikas and I will be your instructor for 3xCCIE course. Today we will be understanding what are the ether channels, what are the different modes of it like LACP, PAgP, how it operates, what are the load balancing mechanisms it uses and how to configure it. Let's get started. Let's look into the ether channels. What are the ether channels? Ether channel mainly is a port aggregation technology. In this technology what happens is, let's assume that between the switches we have two interfaces. Okay, if we leave it by default, what will happen is spanning tree will jump in and shut down one of the port from one side to avoid the loop in the switch. Port aggregation, what it does, it uses the technology to bundle both of the interfaces and convert it to a logical interface so that it acts as a load balancing. It can provide the fault tolerance and even it can increase the bandwidth. All right. There are two types of ether channel, like for example layer 2 and layer 3. You might be hearing it a lot. Layer 2 ether channels, what happens is it is actually a switching. It is working on the layer 2 and you are switching frames on these links, which will be becoming a logical interface. The logical interface will be switching the frames. It could be VLANs, it could be access port, or it could be trunk. But all of them in that logical group should be same. For example, if you are having 5 interfaces in ether channel and they are logically bundled together to make one interface, all of them should be either access or either they should be trunk. Okay, or if you're making layer 3 ether channel, in layer 3 ether channel, since the name describes itself, so you will be routing rather than this switching. So you will be routing the packets. In this layer, what's going to happen, you will be assigning the IP address on both sides and you will try to communicate. In this ether channel, you will be having all of the ports as a layer 3 interfaces so that you are basically technically stopping this switching on it. When it comes to the modes of ether channels, there are two modes of ether channel. One is PAgP, port aggregation protocol. The second one is LACP, link aggregation control protocol. PAgP is a Cisco proprietary protocol, okay, and it can support up to 8 interfaces. All right, just keep in mind, this is the major differences between both of the protocols. At the end, both of the protocols are going to convert physical interfaces into a logical interface. When it comes to LACP, link aggregation control protocol, it can support up to 16 interfaces. Out of these 16 interfaces, 8 is going to be active at all time and 8 can be passive. So for example, out of those active 8 interfaces, one interface went down. Okay, it will automatically take it from the passive and keep the ether channel going up. Does it make sense? LACP is an open standard protocol. 802.3 AD is the standard which is released by IEEE. It's widely used, it's accessible, and it's available for almost all the switches in the market. So you can easily create the ether channels between different vendors as well. The third mode is on. I personally don't recommend it to use the on mode. The reason behind this one is, if you will be configuring a on mode, there could be some challenges coming in. For example, you could be by mistake introduce a loop, a spanning tree loop, or maybe the ether channel never comes up. The reason why is that is when you are basically forcing the switch to make it ether channel, it is not verifying the configuration. So that is your responsibility to make sure both of the sides are matching the configuration. When it comes to the prerequisites of ether channel, it's very simple. You have to comply with that. All of the ports should be part of same category. For example, it could, if it is access, all should be access. If it is trunk, it should be all trunk. If it is layer 3, it should be all layer 3. Okay. The second requirement is the interfaces should be matching the configuration. If one side is LACP or PAgP or in on mode, the other side should be in the same. The next thing is how to configure it. It's very basic difference between both is, if you notice on the screen, one side, if you are PAgP, one side you are mentioning that channel group 1 mode desirable, and the second one is going to be desirable or auto. When you're telling the system to be a dynamic desirable in the trunk, if you remember, what happens? It tries to initiate a trunk. If you remember my last lecture. In the ether channel also, this is the same thing what is happening. When you are mentioning desirable, it is going to negotiate the ether channel. When it is auto, my ears are going to listen only. Okay, I'm not going to speak anything until I receive a message, which is going to negotiate the ether channel. The second thing, when it comes to LACP, it's very simple. You are mentioning active or passive on that interface. When you are mentioning active, it does the same job. When it's active, it will just try to negotiate the ether channel with the other side. But the thing is, you cannot mix and match. If it is active on one side and you configure on the other side, let's say auto, it's not gonna work because the protocols are not matching. So now it's the time to look into how the load balancing works in ether channels. By default, ether channels does the load balancing based on source MAC. So whatever comes up, I will be sending it to particular interface all the time. So I will be just assigning it all the frames to the same interface. There are multiple ways to do the load balancing in the system. You can change it, tweak it as per your demand. For example, you can make destination IP, destination source, destination MAC, whichever you like, you can make it that way based on your need. And the thing is, you can actually tweak this policy in a way that which suits your environment best. For example, when the PAgP makes the interfaces up, it will be assigning by default value of 128 on all the interfaces. So equally, it will be doing the load balancing. But you can tweak it and assign a value of starting from 0 till 255. It will be getting more frames or packet depending on the layer 2 or layer 3. It will be getting more packets when the traffic is going up. All right. When it comes to LACP by default, you can assign from 1 till 6553, and all the interfaces LACP will be assigning 32768 value on all the interfaces. So you can actually tweak it, make it better, or you can give more priority to few interfaces so that they can get better traffic. In the lab, we have our switch 1 and we have switch 2. All right, I have connected two interfaces, Giga Ethernet 1/0/1 and 1/0/2. If you notice that the interface here is green, all right, these three interfaces are green, but this interface is in orange state. So what is the issue here is technically the spanning tree has blocked this port just to avoid the loop. All right, what will be happening is whenever any of this port have an issue or let's say the priority changes, it will be shutting down that interface just to avoid the loops. We have a separate lecture for STP. We will discuss this one, how the STP works and how it selects these interfaces and everything. The thing we are going to do is we are going to make it a ether channel. All right, and we will see how to configure the modes. Let's say we will be configuring it, this one as an active and this one as a passive. So it will be initiating LACP. All right, and the second mode will be desirable. You have desirable auto, we have, okay, this will be initiating PAgP. All right, in this case our lab will be on this one, and I want you to configure LACP in your lab and let me know if it works for you. All right, let's get started on that one, and we will notice once this interface becomes ether channel, orange port is going to go green. Okay, I have switch 1. Let's first see if there is an ether channel. Show ether channel, no information about this. Show ether channel summary. This is another command you should know. This command is important. We will come back to that one. Let's configure the interface range Giga Ethernet 1/0/1 till Giga Ethernet 1/0/2. Let's make it channel group 1 mode. I want it to be desirable. So in this one, what we are setting it up is this Giga Ethernet 1/0/2. I have kept a range command. If you have not seen it earlier, range command, you can configure multiple interfaces with one command. Okay. Before putting this desirable command, let's review how many modes are there. So what are the modes available? So we have active and we have passive, which is LACP, and we have auto and we have desirable. This is gonna initiate the PAgP. The last mode is on. You can try that in your lab. Feel free. There is nothing wrong in the testing it in the packet tracer. So let's configure it to be a desirable on this side. What it says, the interfaces are going up and down. All right, show IP interface brief. You will notice one thing here, that port group 1 is assigned. Okay, it's a logical group. The command which we use, the channel group, all right, channel group 1. Actually, this is the interface number, so you can assign it whatever you want. Okay. We have that one here, and it says it is down. And if you try doing the other way, let's say show Etherchannel summary, and you will notice that the protocol is PAgP and port channel is 1. It is SD. What is the SD? You can read it here. The meaning of S is it's a layer 2 ether channel, and currently it is down. All right, it's changing. Let's go back to switch 2. Let's go to configure terminal interface range gigaethernet 1/0/1 till 2 channel group 1 mode desirable, or we can also configure it auto, so just to showcase that it will still work. So show ether channel summary. Let's wait for some time and it should come up. And if you notice now, something is happening behind the scene. All the interfaces red. All right, what is happening is they are negotiating. The ether channel configuration is communicated, and you will see the status is getting changed. Soon we should have all of them green, and we will see what is happening. So we have all of the interfaces up and they are in the green state. And one thing you must notice here, the interface I shown you in the orange color, that is green now. That's mean STP is not working on this interface anymore. These both of them become a port channel 1. Let's go back and verify if we have this communication up. And actually we already have a log on our screen. If you see port channel 1, it is in upstate, but we want to see it via commands. All right, let's do it. Show ether channel summary. In this one, if you notice now, it says SU now. S is it's a layer 2 and U means it is up, and here, all right, it is in use. And we can see these two interfaces which we have configured and the protocol as well. This is how we configure the ether channels. How many interfaces can be in PAgP and how many can be in LACP? You have to mention in the comment section. So now our port channel is up. We want to have a look on the load balancing, how to change it. If you notice here on my screen, how to verify that, you can do show ether channel and load balancing. There are two interesting things to be noted here. It is by default source MAC. All right, and you have for different protocols what it's gonna do. You can see it here, but we can change it. So let's change it. That I don't want based on the source MAC. Maybe I want it on source IP. Why not? If it is layer 3, okay. But currently it is in source MAC is currently it's a layer 2. Let's make it based on source destination maybe. Let's go back to the lab. All right, let's go to configure terminal, port channel, load balancers, and if you do the question mark, you will see a lot of, but it's not necessary that you only see these options, different options as well based on the port number. They can do it based on the layer 7. They can do based on the port numbers as well. So don't worry on it. You can do the question mark and see what is the right one for you. I want to make it destination MAC. Let's make it destination MAC. All right, let's go back and do the up arrow. You should see based on the destination MAC. This is how we change the load balancing mechanism. The last part in this one is how to change the interface priorities. Technically, we cannot do it on the packet tracer. I will arrange few new switches and we will try to do it on that. So for now, I have copied it in the description how to do that. So in case you need it in the future. And that's it for today. If I have increased your knowledge in any ways, please like and subscribe and let me know in the comment section below what can be improved. Thank you so much. I will see you in the next lectures for CCNA, NPA and IE. I want you to be an expert of networking. Have a nice day.